Hello, I'm Edward Tarte, math teacher. This is another in a series of solution videos to some of my math challenges. The math challenge for this solution video is my Picking Blueberries challenge. Here is how I presented that challenge in the original video. The three generations of the Jones family household is comprised of men, women, and children, more men than women, more women than children. Once a year they have an all-day project of picking blueberries. This past year, a separate quota was assigned to the men, women, and children. Each quota was a whole number of pints of blueberries, the same quota for each man, the same quota for each woman, and the same quota for each child. The quotas were such that 2 men were expected to pick the same number of pints of blueberries as a woman and 2 children, and 3 women were expected to pick as many pints as 5 men and 2 children. All the individuals exactly filled their quota, and a total of 128 pints were picked. My questions are, what were the quotas? The quota for each man, the quota for each woman, the quota for each child. And how many men, how many women, and how many children are in the Jones family household? Here's my solution. In an attempt to figure out the quotas, it sounds as though the quota for each child was the smallest of the quotas for child, woman, man. In order to try to find the ratios, I'm going to assume that each child's quota was just 1 pint. And if that assumption proves to be incorrect, I can revise it. On that basis, we are told that 3 women were expected to gather as many pints as 5 men and 2 children. I'm having W stand for the number of pints in each woman's quota and M stand for the number of pints in each man's quota. That bit of information gives us this equation: 3W equals 5M plus 2. We were also told that 2 men were expected to pick as many pints as 1 woman and 2 children. That gives us a second equation: 2M equals W plus 2. To solve this system, I use this method. I solve this second equation for W. W equals 2M minus 2. I then substitute that value into the first equation. It says 3W. I write 3 times 2M minus 2 equals 5M plus 2. I distribute the 3. 6M minus 6 equals 5M plus 2. I subtract 5M from both sides and add 6 to both sides, and I get M equals 8. I substitute that value of M into this equation. W equals 2M minus 2, that is W equals 2 times 8 minus 2, that's 16 minus 2, which is 14. So W equals 14. So it appears that the quotas are for each man 8 pints, for each woman 14 pints, and for each child 1 pint. We can't be sure yet that those are the quotas. They might be double that. They might be 16, 28, and 2, but given the fact that the total number of pints harvested was just 128, it seems reasonable to stay with these numbers 8, 14, and 1 for now. Now, we were told at the beginning of the challenge statement that there are more men than women and more women than children. So we have to be true to that restriction. We have 8 times some number of men plus 14 times some number of women plus 1 times some number of children equals 128 pints in all. This number has to be more than this number, and this number has to be more than this number. So it takes a bit of trial and error to find what works. For example, if you try an 8 here, that's 64. That leaves 64 more. This has to be less. 5's too big. 14 times 5 is 70. 14 times 4 is 56. 64 plus 56 is 120, which leaves 8 for this, and 8 is too big. It's bigger than 4. So that's an example of something that doesn't work. What does work is 7, 5, and 2. 8 times 7 is 56. 14 times 5 is 70. 1 times 2 is 2. That adds up to 128. And 7 is greater than 5, and 5 is greater than 2. So these quotas make sense. 8 pints for each man, 14 pints for each woman, 1 pint for each child, and the only numbers that work here turn out to be 7 men, 5 women, 2 children. So that's my solution to my Picking Blueberries challenge. Thank you for watching this solution video.